know about what a pattern is? Or can you tell me what is a pattern? Mason, what is a pattern?
It's something that repeats itself.
All right.
I like red, blue, red, blue, red, blue.
All right, so we know that a pattern repeats. Remember, if I'm writing, you are writing. The example that Mason gave was red, blue, red, blue. And then Mason, I'm going to put dot, dot, dot. That tells me that that pattern continues. I'm not going to write it for forever. So that dot, dot, dot is used to say, okay, my pattern is continuing. Remember, if I am writing it down on the board, it needs to be written in your notebook. What else do we know about patterns? Mason gave us a great example and told us that it repeats. Callie, what do we know about patterns?
When you do a pattern, it has to be, it can't just be, like say you did a color, it can't just be a color and then you do it a different way.
Yes. So I think what you're thinking of, Callie, is that our patterns have rules. They can't just do whatever they want. Patterns do have rules. They have rules. In Mason's pattern, the rule is that it always changes back to the previous color. But there could be other rules. Smile, what do you know about patterns? It does have a U that says U. Yeah, you can make a pattern. You can notice patterns in lots of things, right? Like there's a pattern on that back carpet. It repeats. The same pattern shows up again and again. We can make patterns in our numbers, which is definitely what we're going to talk about today. Maverick, what do we know about patterns?
It goes over and over and over.
Goes over and over and over again, usually not stopping unless there is a stop, right? Sometimes there is a stop, right? The carpet runs out, or maybe the piece of paper runs out. But the number patterns could go on for forever. Lydia, what do we know about patterns?
It has to be more than two things in the pattern.
What do you mean by that?
Like it can't just be red and blue. There would have to be red and blue, red, blue.
Oh, so it has to keep going.
Yeah.
I got it. So it can't just be red, blue, done.
Yeah.
We have to show that it's a pattern. Yeah. Otherwise, it's really hard for someone to figure out that that's a pattern. They thought that maybe you're just naming two things. So we kind of have to help show that it's a pattern. You're exactly right. Ava?
You know that like little cushion on?
Yep.
It keeps on going with the pattern.
Yep. And we know that that fabric that made those patterns, or that cushion, is much bigger than that. We can imagine the pattern continuing. Definitely true. All right, today we're going to talk about patterns within numbers. So what we're going to do in our notebook is we're going to start at 0, and we're going to add 2 each time. It's going to feel a lot like skip counting, because skip counting is a pattern that you know. And we're going to write down the sum, that's the answer to us adding every time, until we get to 20. 20 is our stopping number. So everyone underneath, let's write 0, because that's where we're starting. If we're adding 2, what's the next number in this pattern? Go ahead and yell it out at me. 2. We are not on the next blank page. We're just continuing down our notebook. What's the next number?
4.
4. All right, we're writing because I'm writing.
6.
Keep going.
6.
Next.
10.
Next.
12.
Next.
14.
14. Next.
16.
Next.
18.
18. Next.
20.
20. That's our ending number for this pattern. So we should have this string of numbers. 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. This is a pattern. Did you know that this was a pattern?
Yes.
Now, it's not repeating like what Mason was saying, right? It's not going 0, 2, 0, 2, 0, 2, but there is a rule. What is the rule to this pattern that we just wrote down? What is the rule to this pattern? Emma?
It's skipping by 2.
It is skipping by 2, so you mean skipping backwards or skipping forwards? Forward. So we typically say that would be adding, right? If I'm going forward on a number line, I'm probably adding. Do a little caret in between the 0 and the 2. Because that change in pattern is going to be plus 2. That's what happened from that first digit to the second digit, is we had a change in 2. Let's do another caret between the 2 and the 4. Archer, what changed between the 2 and the 4? Huh? So what changed? How did we get from 2 to 4? Which is what? So, skip counting forward or backwards? How do we say forward when we're going forward on a number line? Normally we say plus. We're adding. Adding how much? 2. What about between the 4 and the 6? All right, what's changing between the 4 and the 6? No, there are definitely things changing because 4 and 6 are not the same number.
Plus 2.
We're adding 2. That is what is changing. Every single one. Could I keep going and put carets in between all of those numbers? Yeah. Underneath this, let's write the rule. The rule for this pattern is that we add 2. That 2 looks funny. Add 2. That's the rule to the pattern. So sometimes our pattern is not going to repeat, especially when it's dealing with numbers. It might just be a rule that we're changing the number every time by. So far, so good? So the next pattern we're going to look at, you've definitely seen before. Even and odd numbers. Give me a Me Too stand if you've ever heard of even and odd numbers. I want you to put a subtitle. So that means underneath that line that you just drew in your notebook, I want you to write even and odd numbers. It's kind of like a mini title, but you're putting it in the middle of the page instead of at the top. It's called a subtitle.
So you write subtitle?
No, you're not writing the word subtitle. You're making a subtitle, which is going to be even and odd numbers. You're writing those words.
In the middle of the...
So you drew a line in your notebook, right, Addison? So under that line, this is your new subtitle.
Can we do the question mark?
If you want to. Even and odd numbers follow a pattern. Let's talk about that pattern. Let's start with even numbers.
What do we write on the...
We're going to start with even numbers. What is the rule to be an even number? Try to think of it in like counter form. Like if I said make an even number with your counters, what would that look like? Lydia, what do you think?
You have to be able to have 2 of the same numbers and put them together and make a number.
Beautiful. They have to have a buddy. Have you ever heard that before?
Yeah.
So let's pretend we're making the even number, let's say 6. 6 is an even number. If I were to draw counters out, which I'm going to do, just some little dots. Here's my 6 counters. I know that it's an even number because I can make complete groups of 2. Hey, I've heard that language before. Have you heard that language of groups of two? Weird. Even in odd numbers, so building groups, just like what we've been doing. Let's circle some groups of two to prove that this is an even number. Here's a group of two. Here's a group of two. Here's a group of two. Spelling.
And to make sure it's an odd number, you have to add doubles.
Hang on. Right, we're going there. Keep in the back of your brain. Underneath that, always can be organized in groups of two, aka buddies. Might have heard that. Our even numbers have to have a buddy. So the number was 6, but I can organize that 6 into a group 2, and a group of 2. They all have a buddy. Does that make sense? Is there anyone confused what I'm saying? Avery.
I understand what you're saying,
Yes.
but I wasn't here and I'm kind of confused.
We're doing even numbers. We took the example of 6, and Lydia told us that in order for it to be an even number, it has to be arranged with a buddy system. They have to match up. So if I put up 6 counters in front of you, because I do know that 6 is an even number, I can prove that it's even because I can organize it in groups of 2, which you probably heard as a buddy, maybe when you were learning this in 1st or 2nd grade. Callie?
How I know that if I have 6, I look at the 3 and then I see if there is 2 groups.
Okay. Think of it as groups of 2, though, because remember, even numbers have to have a buddy. That will work for 6. I'm just not sure it'll work for every number. Think of it that way.
Yeah.
Okay. So if we know that about even numbers, Bowen, I know you're getting ready to tell us about odd numbers. What do we know about odd numbers?
Oh, so odd numbers you always have to add not doubles.
Yes.
And with even numbers you have to add doubles, the same number together to make even numbers.
I love that. You remember when we were talking about names for groups of 2? And we said that pair was a name for a group of 2. Another name, Art, is a double. Let's put that up there so we remember that. Bowen just gave us another great word to describe groups of 2. Double. If you've heard of doubles, then we're just making 2
All
groups.
doubles are even numbers.
All doubles are even numbers because if it's double, it's going to have a group of 2. Awesome. Emma?
Odd numbers are you always have
You always have 1 left over. I remember it as 1 odd man out. So, for instance, I know that 7 is an odd number. Just like in even numbers, I'm going to make my 7 dots, my 7 counters, just to prove it. 1, 2, 3, 4, 5, 6, 7. Go 7. Go ahead. In order to prove it, I'm going to pretend like I'm trying to see if it's even. I'm going to start making groups of 2. All right, well, here's one. Cool, maybe it's even. Here's another one. Awesome. Here's another one.
1 left over.
And we have 1 left out. So because I cannot make a complete pair or a complete group of 2, that's how I know that it is odd. Always nope, those are not the right words I want to say. Always is organized in groups of 2, except with 1 left out or left over. are groups of 2 in odd numbers, with the exception of probably 1. But every other odd number can be grouped in 2. There will just always be that last person, last dot, that cannot form that group of 2. That's what makes it odd. I'm going to repeat what Archer just said because I love it. Archer said, I know one more thing about an odd number. You always make an even number, and then you add 1 more.
I don't have any more space.
I didn't say you had to write it. I just want to expose you to that genius because it was amazing. Can someone explain what Archer's talking about? Because I love it. I'm going to say it one more time. Archer said, to make an odd number, you always make an even number plus 1 more. I love that. What does that mean? Like written in fortune cookie. What does that mean? Bowen, what does that mean?
He's basically saying doubles plus 1.
Yeah, it is like doubles plus 1. Good connection. Avery, what does that mean?
So it's kind of like if you have an even number, and you're like, oh, well, obviously I didn't want this to be an even number, but I know if I have an even number, then it's kind of like a pattern.
It is a pattern.
Even odd, even odd. So that means I just need 1 more to make it odd.
Beautiful.
So then you add.
Beautiful. I love that. I love that. Probably seen something similar to this in multiplication chart. We're not going to look at a multiplication chart yet, just because we haven't gotten there yet. We will look at one later. But raise your hand if you've ever seen some kind of chart that looks like this. I'm not saying you know how to read it, but you might have seen it before. So this is an addition chart. Usually we don't see addition charts, we usually see multiplication charts. But this is how we read it. I have one set of numbers at the top that are gray, and I have another set of numbers down the side that are gray. Those are my 2 add-ins. So I would pick one up top, one on the side, and that's what I would add together. So let's pretend I want to add, let's say, 3 and 5. I'm going to put my finger on 3 and I'm going to put my finger on 5. And the way that this works is I'm going to drag my 5 finger across and my 3 finger down until they run into each other. I'm going to do this with a marker just so you can see it. So I'm going to move my 5 across and my 3 down, and they run into each other at the 8. Do we see that? So the sum of 3 plus 5 is 8. Give me another equation, and we'll solve it on that addition chart. Marley?
5 plus 7.
5 plus 7 is 12.
Whoa, that's cool.
Isn't that cool? Callie, give me another one.
9 plus
9 plus 10.
2.
19.
Oh, God.
Alright, I want you to take a second and look for some patterns that you might notice in that addition chart. What are some patterns that you see? Alright, what are some patterns that you notice in this addition chart? Ava, what do you notice?
8 plus 6.
Okay, that's not a pattern though, that's just an equation. What do we notice? What patterns do we see? Addison, what pattern do you see?
I see the pattern of where we started at 0 and 2, 4, 6, 8, 10.
So say that again.
I saw the pattern where we started at 0 and then went to 2, kind of by 2s.
Where? Where am I looking?
0.
I don't have a 0.
Oh. So I could start at 1 and then go by 2.
So I start at 1,
And
and then I go where?
you can go to 3, 5, and 7.
Okay, but I don't have a 3 next to my 1. I don't understand where I'm supposed to be. I have a 2.
I'm talking about, I'm saying like jump 2.
Okay, but I'm not going to jump 2 because I got to go what's right next to me. Lydia?
I don't have a that it's kind of like a 100 chart.
It is similar to a 100 chart. Callie, do you see a pattern?
They're both kind of like,
Or
they're kind of like squared.
what do you mean by that?
They're like, so like you go to a number, and then you like kind of like turn, and then you go to the number.
Can I share a pattern I noticed? Every row, when I go across, is adding 1. Every row, when I go across, is adding 1. Do you see that pattern?
No.
Doesn't matter where I start, but as soon as I start going across my rows, I add 1. Can you find another pattern? Jordan?
That all the gray numbers, they all have the same numbers in the gray boxes. Like the one that goes on the side.
Okay, I don't think that's a pattern. I think that's just an observation. Remember, pattern we have to keep repeating. There's a rule to it. So that's why I said when we go across every row, all of those strings of numbers add 1. Avery?
So you know how there's like 1, 2, 3, 4, 5? It's on every one, but it might change and add another digit, but it's still a pattern of the same number.
Going across?
No, if you go down.
If I go down, Avery's noticing, hey, if I go down each column, I add, I add 1.
But it's still the same number.
Bowen, you found one?
I noticed that you can also subtract.
How to explain that?
You can also subtract by going that way.
Yeah, Bowen noticed, hey, I could also say that my pattern is subtracting 1. I just have to start on this side. Do you see that? If I start on this side and I go that way, then my pattern is subtracting 1. What if I start down here and go up?
Oh.
Is that another subtracting 1? Each of those numbers change by the same amount. There's a rule, not a pattern, that they're changing. If we start going from the bottom up, they're subtracting 1. If we start at the top and go down, they're adding 1. Rogan?
14 and 7.
Okay, so that's an example of an equation. We're looking for a pattern. Some of you probably noticed. What about 12 and 11? Okay, that's not a pattern, that's just an observation. I did notice a pattern. Look at these numbers going diagonal. Can you notice a pattern if I go diagonal? If I go diagonal, can you notice a pattern? Raise your hand and tell me if you found it. If I start in the corner and I go diagonal, what's happening to my numbers? Jordan?
You're counting my 2.
Jordan noticed, hey, if I go diagonal and I continue that pattern, each of those numbers is increasing or adding 2 each time. Owen, what else did you notice?
You can skip count.
I can skip count. That's my pattern. Yeah, Connor.
I don't know what a pattern, but if you also go diagonal to the other way, every single one will have like that number. So like 12, 12, 12.
Yeah. So Connor's noticing, hey, if I go diagonal the other way, my pattern is plus 0. It's the same number over and over and over again. Avery?
Do you know how the other diagonal part? Look on the other way. It's counting the same thing but higher numbers.
Nice. Awesome. All right, so we're going to do what's called a proof. Proofs happen all the time in math. It's a way for mathematicians to prove that something works the way that it does every single time. Where you're close correctly, please, Marley, sit up. So we're going to look at this statement. And we're going to see, is this true or false every single time? So for instance, you've dealt with proofs. You've learned that 2, number 2, is an even number. That is true every single time. That's what a proof is. So we're going to look at some statements, some sentences, and see, is that true every single time? So here's our sentence. On the next blank page, write that sentence down. Because we're going to figure out, is this true every single time? The sum of 2 even numbers
On the next page.
is always even. Yes, you're writing that sentence at the top of the next blank page.
No title.
There's a couple of words we're going to circle. Mark, you gotta write this down, please. Just to make sure that we know what they mean. Circle this word sum. That is not some like I have some M&Ms. That's a different word. It just sounds the same. You probably have heard this word before. That word sum, spelled S-U-M, is a math word that means the total of an addition equation. So above the word sum, after you circle it, we're going to write total. It is technically the total of an addition equation, but for right now, we're just going to leave it at total. Lydia, do you mind closing my door, please? Thank you. All right, so let's think about this. I have an even number. Think of an even number in your head. One that is made in those groups of 2. Let's pretend I add another set of even numbers, more groups of 2. Is my total even or odd? I'm going to say that again. You've already thought about it. That's great. Think of an even number. Think of those even pictures, those groups of 2. And I'm going to add more groups of 2, more even. If I smush them together, do I get an even number or an odd number? Marley, what do you think? Why do you think that?
Because it's 2 even numbers. So like, let's say 2 plus 2 or just 2 even numbers.
Would I ever, if I add groups of 2 plus groups of 2, would I ever have 1 left over? No. Bowen?
100.
So the question is, if I add an even number plus an even number, any even number, would my answer be even or odd? Why do you think that?
Because you could add 52 to get 100.
Yes. I'm just counting in groups of 2. So is this true?
Yes.
Yes, let's write it. True.
I said that you can count.
That is true. Because if I'm counting even numbers, I will always have groups of 2. And I could even give an example like Marley did. Marley gave the example, okay, she had 2 and another group of 2. That would definitely still equal an even number. There's her evidence. Lydia?
When you skip count by 2s, you're always skip counting even numbers.
I don't
Yes.
know how
That's
to
good
figure it out.
pattern. Callie?
I think it's even because if you had an even number and you added 1, that would be an odd number. But if you added 2, it would be an even number.
Beautiful. I'm starting with a group of 2, some kind of even number. And if I keep adding groups of 2 to it, or if you should be writing, then I'm never going to get to that odd number. I'm not going to have one magically just appear. I'm always adding groups of 2. Awesome thinking power. Avery, what's up? All right, here's our last one. This is the only other one we're doing. The sum of 2 odd numbers is always odd. Write that down and then we're going to think about it. So this is our new subtitle. The sum of 2 odd numbers is always odd. We're going to try and think about that, see if that's true. It could be any odd number. Remember, we're at groups of 2 with 1 left over. Then we're going to add another odd number. Groups of 2, 1 left over. Is that going to be odd? Okay. Maya, what do you think? Okay, so the question is, if I add 2 odd numbers, is it going to be odd? What do you think? Okay, wait, 3 and what? Okay, but 2 is an even number. Remember, I need 2 odd numbers. 3 will work. So I've got 3, and remember 3 looks like this. This is how we know that it's odd. We've got that 1 left over. Right over there? Right over there? Plus, we need another odd number. What other odd number would you like? 7? Chill out. 1, 2, 3, 4, 5, 6, 7. Okay, we're going to do our groups. We're going to prove that it's odd. Okay, when I add those together, is that going to be an even number or an odd number?
Even. You have 2 left over, and then you divide them together, and then you make it like another 2.
Say it again for the friends in the back.
You have 2 odd numbers, and you divide them together, and then you make another 2.
If we have 2 odd numbers, we're always going to have this one odd man out. Which means when I add them together, will I have any more?
No.
No, because when I add them together, we've got our 3 up top. 1, 2, 3, 4, 5, 6, 7. And then these last 2 odd mans can become a partner. That's what you were thinking? Brilliant. So when I add 2 odd numbers together, is my answer odd? False. False. 2 odd numbers. Numbers is always an even number because what Samaya said, the 2 left over form a group of 2. Great job, Samaya. This is where we are actually going to practice. That's all we're going to work on right now. I think I might do another activity. I'm not quite sure what I want to do. However, your opinion is quite exact. However, great job thinking about patterns. We're going to be continuing to do a lot of work with patterns because patterns are skip counting. And we've been talking about when we group things, like we did yesterday, we're just skip counting. So we're going to be playing a lot with patterns and how those patterns change. Make sure you got this written down. Once you've got it written down, you can put your math notebook over.